Alright, welcome back guys. So we're going to continue from the last video. We stopped on example 2. That was when we are just trying to figure out the probability of guessing 3 questions right out of 5 using the listen technique. Just listen out how many possible ways we can guess 3 questions correct out of 5. And then there are 32 in the sample space because each question has two outcomes. So 2 to the 5th, there's 5 questions total. So 2 to the 5th would be 32. We realize that listing out these possible outcomes to figure out the probability or the chance of that particular example, it can take a while. So now we're going to introduce a shorter way, or not quite shorter way, but a much better way, and it's called a binomial probability formula. So this is the formula that allows us to calculate any probability for any event from a procedure that considered to be a binomial random variable. So let's get to that. So the formula said that is P of X. So P of X is denote for the probability of getting X success outcomes or X success trials out of N trials. Okay, so that's what P of X stands for. So here's the formula. It is NCX P to the X power times Q to the N minus X, and this is for X's discrete values, so from 0 up to N. NCX is the combination formula, so it is equal to N factorial over N minus X factorial, and then times X factorial. P to the X times Q to X. And Q, we can look at that as 1 minus P to the N minus X. So the factorial and the combination and permutation formulas from the previous chapter that we skipped, but we don't need to know too much about it to figure out how to do this using a calculator or just understand what that is. So down here we have few notations, N, X, P, Q, P of X, right? So I have that there. N is denotes the fixed number of trials in a procedure. X denotes the number of success in an N trial. So X can be any whole numbers between 0 to N, inclusive, meaning it can equal to N. P denotes the probability of success in one of the N trials. Q denotes the probability of failure in one trial. That means 1 minus P is equal to Q. And then P of X denote the probability of getting exactly X success among the N trials. So this is the formula. So we could use the formula in this case. That's what we have the NCR from the previous example there. So let's apply that formula in this next example. It's like given that there is 0.85 probability that a randomly selected adult knows what Twitter is. Use the binomial probability formula to find the probability of getting exact 3 adults who knows what Twitter is when 5 adults are randomly selected. That is, find P of X equal 3. So we want to find the probability of getting exact 3 adults who know what Twitter is out of any random 5 people. Okay. So first we list out the number of fixed trials. So that is 5. X is the number of success we want to find out of 5. That is 3 adults. P is the probability of success, or the probability of 1 adult know what Twitter is. That is given 0.85. And then Q is the probability of 1 adult not knowing what Twitter is. That is 1 minus 0.85, which is 0.15, right? So here's other things we have to list when we do this type of problem. So now we say, what is the probability of exactly 3 adults out of any random 5 adults that know what Twitter is? So that is NCR times P to the X times Q to the N minus X. So N is 5, R is 3. In this case, is NCX. Times 0.85 to the X, in this case 3, times Q is 0.15 to the N minus X, in this case 2. So we can use the factorial breakdown as up here, okay, and figure out what 5 choose 3 is. Or we can use the calculator. So that calculator features is under math, so we want to go math. P PRB, which is probability. So what we want to do first is type in the phi, click math, PRB, and then do NCR, which is the third option here, and then that type in 3. That give us 10 possible way of you know, getting exactly 3 of those out of 5 that know what tweet is. So we can say 10 times 0.85 to the third times 0.15 to the second, and we crank this up into our calculator, and then that should give us about 13%, 138, so 13.8%. So if we go out on the street, based on this example, based on this study, any random 5 adults we selected, the chance of that 3 out of 5 of those who don't know what Twitter is about 14%. And again, nowadays everyone know what Twitter is, so this data could be outdated. So that's what that example is referring to. Let's do another one. Consider rolling a fair die 6 times. Find the probability of getting exact 2 5s out of 6 tosses. So we roll in the die 6 times, and then we want to see out of those 6 tosses how many times a 5 come up. So n is 6x. In this case, is we want to figure out 2. We want to get 2 roll that is considered to be a 5. So getting 2 5s out of 6 tosses. That's what X stands for. P is the probability of success of one single trial. So that means what is the probability of getting a 5 in a single toss? For a fair die that has 6 sides, so that would be 1/6. Q is the probability of failure, the probability of not getting a 5 from a single toss, that is 5/6, right? Probability of getting a 5 from one toss. All right, so that's what P is. So now we're ready to do the formula. So we say, where is the probability of getting 2 5s out of 6 tosses? So that is n choose x, so 6 choose 2 times P is 1/6 to the x in this case is 2, Q is 5/6 to the n minus x in this case is 4. And if we crank that in our calculator, that should give us the answer of 20%. Okay, so I'm gonna show you guys how to do that really quick. So we're gonna do 6 choose 6 to 2, right? And then times 1/6. So we do 1/6, 1 divided by 6 raised to the 1/6 raised to the second times 5/6 raised to the fourth, and that should give us about 20%. Okay. All right, next questions. So this question will help us get to the next part, where the procedure of the selections, what we're observing. The trials are large, and doing this formula is no longer efficient or not as helpful we want to, or it takes longer. So this next example is going to lead us to the next, well, not quite yet. I think the next example is where, example 6, this is where we looking at more statistics computation formula using technology. So let's start with example 5 here. Based on a recent Harris poll, 60% of adults believe in the devil. Okay. Assuming that we randomly selected 5 adults, find the probability that exactly 3 out of 5 believe in the devil. So we're going to say, what is the probability of x equal to 3 out of 5 that believes in the devil, using NCX, P to the x, Q to the n minus x. And we know that in this case is 5 adults selected. We want to find out 3 out of 5. P is the probability of 1 adult believing in the devil. That's 60%. That's pretty high. Q is 0.4 because 1 minus 0.6 is 0.4. So we can plug that into the formula. We're going to say 5, choose 3 times 0.6 to the 3 times 0.4 to the second. Okay. And if we plugged into our calculator, that should give us about 34%, 56. That's pretty high. So if we go out on the street and said, pick any random 5 adults and figure out that the chance of exactly 3 out of 5 believe in the devil is about 34%. That's pretty damn high. Okay. Next question. Find the probability that the number of adults who believe in the devil is at least 2. Okay, so this is asking for the probability of x greater than or equal to 2 out of 5. That means probability of 2 or more. That means we want to figure out the probability of x equal to 2, add it to the probability of 3, add it to the probability of 4, add to the probability of 5. That's what the OR means, is the addition rule, right? So we will have to do this 4 times. We will have to apply the probability, the binomial probability formula 4 times to get this answer, because it's at least 2. At least meaning 2 or more. Okay. So chances are we probably don't want to do this, go this route. We had this rule from the previous chapter, and it's called the complement rule. Right? Remember the complement rule of probability. That's saying that if we have P of A plus P of A bar is equal to 1, and we can modify this by saying that 1 minus P of A bar is equal to P of A, right? So that's another alternative formula from that P of A plus P of A bar equal 1. So what we can do here to find the sum, we can say that I can take 1 minus the probability of A bar. A bar in this case, the event of complement to this, the opposite event to this here. So we can say that 1 minus the probability of getting less than 2 adults who believe in the devil, right? So less than 2, we can say the probability of 0 adults out of 5, or 1. That's what less than 2 mean. So in this case, we just have to do only 2. We only have to apply the binomial probability formula twice. Okay. So it's a little more manageable than doing 4 times. Okay. So if you do the formula correctly, you should get 0.012 plus 0.0768, and then subtract that from 1. That should give us 91%, 96. Okay. All right, so I'll let you guys work on this part on your own here. Apply the binomial probability formula twice to get these numbers, and then subtract that from 1. All right, so I believe I'm going to stop on this video, and I'm going to say the last page on the next video is going to contain a lot of information. So by now you probably realize, okay, is there a much quicker way to do this without applying the binomial probability formula over and over again? And the answer is yes, and that's what the next page is going to tell us. Okay, so I'm going to save that on the next page.